Today I would like to start Ohm's law applied to the circuit. So here, first of all, what is the meaning of the circuit? You have to know it. So you are already familiar that circuit is nothing but a closed path or flow of electric current. So it is a means, it is a medium through which electric charges are flowing. That is nothing but the circuit. So you know that this is a circuit. For this circuit, you are applying the Ohm's law. I mean that. What do you mean that? So actually, in circuit applications, you are applying the Ohm's law to the circuit. So Ohm's law applied to the circuit means Ohm's law applied to the circuit means so for particular voltage, how much current is going to generate in the circuit? Is it? In order to generate this much current, how much will the resistance in the circuit? All these parameters will going to evaluate in this Ohm's law applied to the circuit. In order to evaluate, in order to find out the different parameter, you require an expression. So let us see. Today we would like to derive an expression for current. I mean that with the help of, you are going to apply this Ohm's law to the circuit. So with the help of this Ohm's law, you will going to derive an expression for the current. So for this, in order to find the current in the circuit, so you consider a simple circuit. It is a simple circuit. There are two types of circuit. One is the simple circuit, another is the complicated circuit. Bear in mind, Ohm's law is applicable only for the simple circuit, to analyze the simple circuit. Whereas the Kirchhoff law, it is useful for the complicated circuit. Complicated circuit is one which cannot be reduced into simple. That circuit is known as the complicated circuit. In other words, the complicated circuit which deals with two or more resistors, two or more circuit elements, two or more sources of EMF. So that circuit which cannot be reduced into simple circuit, such a circuit is known as the complicated or complex circuit. So here we are considered that a simple circuit which contain one battery, one resistor. So you are consider a resistor whose resistance is R. So to this a battery and plug A are connected. So as you know that whenever you are satisfying the three conditions for the any circuit, current is going to flowing in the circuit. As you know that as soon as plug key is inserted in the circuit, the charges are beginning from the begins to flow from the negative terminal of the battery towards the positive terminal. As a result, conventional current is flowing from the positive terminal of the battery towards the negative terminal. Say that I is the I ampere of current is flowing through the this external resistance R. So whenever the current is flowing through the any circuit element, so what happens that across the circuit element a potential difference is going to develop. So in this case potential difference is V, whereas the R is the external resistance. So this is a battery of EMF E volt. So EMF of E volt. So its internal resistance is denoted as R1. So Ohm is an internal resistance, is a small resistance, is less than 10 ohm. So which is lies inside the cell itself. That's why we are calling that internal resistance. Let us see while studying. We are going to discuss that. What is the internal resistance? Is it? What is its value, etc. So now today we are going to concentrate. So expression for the current. Ohm's law we are going to apply for this circuit. With the help of the circuit, we are going to derive an expression for the current in the circuit. Is it? So let us see, as I said, that you are consider a resistor of resistance of resistance of resistance R. So you are consider a resistor whose resistance is R ohm. So for this and its internal for this a battery a battery of EMF E volt is applied and its internal resistance of cell internal resistance R. So the resistance which lies inside the cell, which is known as the internal resistance. So let us see. So as we know that, so in order to constitute the electric current, there should be potential difference across the ends of the conductor. As a result, whenever that potential difference is there, as long as potential difference is there, the current will go into, charges will go into flowing in the circuit. In order to derive, in order to transfer, in order to transport a unit charge all around the circuit, which is known as the EMF of the circuit. So that means that, EMF of the cell. So this is this cell which develops the potential difference across the resistor. So one is that there is a conducting path. Second is that across the ends of the conductor there is a potential difference. And if the supposed circuit is closed, you are satisfying the three conditions. As a result, electric charges begins to flow from the negative terminal of the battery toward the positive terminal. So conventional current is opposite to the electronic current. So that the electric charges are flowing negative terminal towards the positive terminal. Conventional current is flowing from the positive terminal of the battery towards the negative terminal. So that means that, so you have to know that what is an EMF? What is the definition of electromotive force? As I said that energy spent or work done in transferring 1 coulomb of charge all around the circuit in which cell is connected. I mean that including the cell. You see. So I mean that, say, unit charge. In order to simply say, if I change the position of the resistor, I too spend certain amount of energy. Likewise, in order to push the charge from one point of the resistor to the another point, one point to another point, you require electromotive force, I mean that EMF. So when the EMF is there, EMF is formed, potential difference is going to generated as a result. So electric charge is going to flow in the circuit. So that means that, as I said, that electromotive force is nothing but the work done or energy spent in transferring unit charge all around the circuit. This is nothing but the EMF of the cell. EMF of the cell is nothing but the energy spent or work done. What purpose? In order to transfer unit charge all around the circuit. All around the circuit means through the external resistance to derive the unit charge through the external resistance as well as internal resistance. While driving the charge through the external resistance and internal resistance, cell has to spend certain amount of energy or cell has to do the work. So that means that total energy spent by the cell is equal to sum of the work done while transferring unit charge through the external resistance and some part of energy it is spent while transferring charge through the cell itself. I mean that these two work done, if you sum up, I mean that add up, you will get the how much energy spent by this cell. So that is from the definition of the definition of the from the definition of the from the definition of from the definition of EMF, that is nothing but the total energy spent, that is denoted by what? E. Total energy is equal to sum of the work done in transferring unit charge through the external resistance, which is denoted by V, and some of the and another part of the energy which is used to in order to transfer unit charge through the what? Internal resistance of the cell, which is denoted by what? V dash. So that means that total energy spent by the cell, which is equal to part of the work done while transferring unit charge through the external resistance, another part of the energy spent in order to transfer unit charge through the internal resistance of the cell. On summing these two work, work done or energy spent, you will get the total energy spent by the cell in order to transfer unit charge all around the circuit. So here W represents the work done. So this V represents the work done while shifting the charge, while transporting the charge, while transferring charge from through the external resistance R. So which is calculated by using the Ohm's law. So expression for the V, that is PD across the external resistance, V stand for the, so otherwise you can say that PD across R plus PD across small r. So that is nothing but as I said that PD across R by Ohm's law, as you know it. So by Ohm's law, IR. So as you know that expression for PD, V is equal to I into R. Similarly, so PD across internal resistance of the PD across the cell, that is nothing but the I into small r, because resistance is inside the cell, resistance is smaller. So here you see that I is common in these two terms, therefore you take outside IR plus R, which gives an expression for E. So this is a plus. So this is, now we need an expression for I. In order to bring an expression for I, so just on rearranging this expression, so you have to rearrange this expression. So this expression can also rearrange that I R plus R, which is equal to E, or else you can say that I is equal to E upon R plus R. With this expression, I can find out how much current is flowing in the circuit, provided you have to know what is the EMF of the cell, what is the external resistance value, what is the internal resistance value. If these values you have to substitute in this equation, in this expression, you will get the how much current flowing in the circuit, right? So far we have studied that what is the EMF of this cell. It is as I said, that total energy spent by the cell in order to transport unit charge all around the circuit in which cell is connected. Is it? So now this term, we know the definition of this. From this definition, we got that E is equal to, that is total energy spent by the cell, which is denoted by E, electromotive force, which is equal to a part of energy spent across the external resistance, another part of the energy spent through the internal resistance, together we will get the total EMF of the cell. Then question is that how to find the work done while shifting, while transporting unit charge through the external resistance as well as internal resistance. By using Ohm's law, PD across external resistance is V and PD across internal resistance is V dash. So from Ohm's law, so PD across R is equal to I into R plus IR, where R small r represents the internal resistance. On simplifying that, taking I common, that is, you will get an expression like this, and realizing that finally you get an expression for current. So now let us see. So if you see that, what we will find it is, that is current, in other words current in the circuit. I represent the main current or main current in the circuit, which is equal to, it is the ratio of EMF of the cell is equal to total resistance of the circuit. In other words, you can say that, so current in the circuit, main current in the circuit is equal to net EMF upon net resistance. Net means total resistance. See, so this is what expression for the current in the circuit. Now while we are studying that Ohm's law applied to the circuit, so we are come across what terminal PD and open and closed circuit is it. So let us see what is a terminal PD. It is the potential difference across the terminals of the cell when the current is flowing through it, when the circuit is closed. I mean that PD, terminal PD, in short form we can write it is TPD. Terminal PD of the cell. What terminal PD of the cell? Which is equal to terminal PD of the cell. It is nothing but the potential difference across the terminals of the terminals of the cell or terminals of the two electrode when the circuit is closed. When the circuit is closed means the closed circuit current is flowing. During that time, whatever the PD, you got it across the terminal of the cell, which is known as the terminal PD. Then usually what happens that terminal PD is approximately equal to PD across the external resistance. I mean that this TPD, where T stand for terminal, P stand for, PD stand for potential difference. Terminal potential difference approximately equal to or equal to resistance PD across the external resistance. Terminal PD is equal to the PD across external resistance, which is represented as R. External resistance is designated as R. So if it is the case, so what is the from Ohm's law? You know that for expression for PD, as you know that V is equal to I into R from Ohm's law. You can write it is. So now we are already familiar with expression for current. So expression for current, as you know that just we got it an expression for this expression, you have to substitute in this equation. On doing so, what happened that V is equal to I is equal to net EMF, that is E upon net resistance R plus R. Net resistance is external sum of external resistance and internal resistance, that is the net resistance of the circuit. So this is multiplied by R. So this expression can also be written as simplified. So ER R plus R. For your convenience, this expression can also be written, that is V is equal to E R plus R upon R. This R shifted to the denominator, and doing so I will get this type of expression. So further simplification, this can also be written as E upon 1 plus R divided by R. So that means that V is equal to E upon 1 plus R upon R. So now what you have to do that, you have to prove that in this expression, that is terminal PD, is it? We stand for the terminal PD or PD, terminal PD across the terminal cell, which is equal to EMF of the cell, which is equal to EMF of the cell. This is possible. You have to prove that. You have to show that V is equal to E. So in order to show that V is equal to E, there are two possibilities. If under these two conditions, if R is equal to 0, R over R is equal to infinity. So under these two conditions only, we can prove that terminal PD is equal to EMF of the cell. So let us see, we will see that how the terminal PD, which is equal to EMF of the cell, and what is the open circuit and closed circuit based on this expression, I can show you. So now, so V is equal to, now it is E. So in this case, you see that in this our expression you have to substitute that R, whether R is possible to 0, R cannot be 0, because every cell has got some amount of internal resistance. That means that this is impossible. R cannot be 0. You have to search for second possibility, whether R is equal to infinity. As R is equal to infinity if it is open circuit. So R is infinity is equal to R resistance will be infinity. So if capital R and the external resistance is infinity, then it will see that in this expression you substitute that so E is equal to E upon 1 plus R divided by infinity. So this term value is equal to 0. This term is equal to 0. If it is the case, then finally this expression will become V is equal to E upon 1 plus 0, which amounts to the E divided by 1, that is nothing but the E itself. So therefore V is equal to E. So we have proved that the terminal PD of the cell, which is equal to EMF of the cell, provided cell is open. Remember that? So sorry, circuit is open. If the circuit is open, then terminal PD of the cell approximately, or it is equal to EMF of the cell. Now we are using that open circuit here terminology. What do you mean that open circuit? In the what happens that in open circuit, whether the current is flowing or not. So you see that in the open circuit current will not flow, because you know that from Ohm's law, R is infinity. By analyzing Ohm's law, as you know it, I is equal to, when R is tend to infinity, V upon infinity. When R is infinity, R is bigger, the current will become 0. So here I is equal to V upon infinity, which is equal to I is equal to 0. That means that no current is flowing in the open circuit. In the open circuit, current will not flow. So that means that open circuit is one in which current will not flow. So such a circuit is known as the open circuit. So then what is a closed circuit? It is a simple logic. That is opposite of the open. It is a closed circuit is one in which a definite amount of current is flowing and definite amount of resistance is there. Such a circuit is known as the closed circuit. So we have shown that here. So far we have discussed that what is the circuit. So how to apply the Ohm's law by considering a simple circuit is we are say that difference between simple and complicated circuit. Simple circuit is one which contains only one battery, one circuit element. So circuit element, it may be resistor, capacitor or inductor. So here only one source of EMF we have taken and one resistor, therefore it is in a simple circuit. So this simple circuit contains a battery and plug-in series. So this is we are considered simple circuit. In this simple circuit, I stand for the current and we stand for the PD across the external resistance, where R stand the external resistance, small r represent the internal resistance, E stand for the EMF of the cell. The question is that what is an EMF? It is nothing but the source of what? Energy or sheet of energy. So this source of energy, it is required for what purpose? In order to transfer unit charge all around the circuit, which is known as the what? EMF of the cell. So in other words, you can say that is total energy spent in order to transfer unit charge all around the circuit. Then question on that, usually when the EMF of the cell is said to be 1 volt. So EMF of the cell, EMF of cell 1 volt. So EMF unit of SI unit of EMF is volt. When we are saying that EMF of the cell is 1 volt. So you see that if 1 coulomb of charge, 1 joule of work done in transferring